Last lecture we have defined greatest integer function and fractional part function. I solved a couple of problems. The next one is solve 4 fractional part of x is equal to x plus greatest integer x. Solve and get me the solution set. Let us do it by 2 methods. One method, I mean, this is elementary problem, but still 4 fractional part of x is greatest integer x plus fractional part of x plus greatest integer x. That makes it 3 fractional part of x is equal to 2 greatest integer x. Hence fractional part of x is equal to 2 by 3 times greatest integer x. Now we know that fractional part of x is between 0 to 1. Equality at 0. And therefore, we can have this. 2/3 of greatest integer x should be between 0 to 1. This implies 0 less than equal to greatest integer x should be between 3 by 2. Okay. Therefore, equality allowed. Therefore, this fellow can be 0 and this fellow can be 1. Only 2 possibilities, 0 and 1. Because it has to be integer which is smaller than 1.5 and greater than 0 or equal to 0. So, I think that is what you get, 2 values of greatest integer function x. So, if greatest integer x is equal to 0, then you get fractional part also equal to 0. But if greatest integer of x is 1, then you get fractional part of x as what, 2 by 3. Okay. So in this case it is 0 plus 0, the answer is 0. In this case 1 plus 2 by 3, the answer is 5 by 3. That is what is your solution set. However, it is much faster if you remember the graphs. Greatest integer would look like this. Step function. Fractional part of x will look like this. No. What we are supposed to do? We are supposed to solve these two. No? So, okay, greatest integer you are supposed to get it down by 2 by 3, not 1, 1. So, greatest integer is multiply the greatest integer, y is equal to 2/3 of greatest. This. So basically the values that you have otherwise, hello, so this is 1, so this is 1, so you go 2/3. 2/3 of 1, go up to 2. Then 2/3, that is 4/3, you go here and plot. Okay, so this will ensure that you get first root as 0 because it is going to go like this, and second root will go somewhere here. This is fractional part of x. So you have this point and this point as your solution. This and this, which is 5/3 and 0. Okay. Next. Solve x cube minus greatest integer x is equal to 4. Now this problem is good to solve graphically. So what you need to sketch is y is equal to greatest integer x and y is equal to x cube minus 4. So this is our y-axis, this is our x-axis, and you know y is equal to x cube will pass through origin. You are supposed to come 4 units down and sketch exactly the same graph. I mean, right now we need to do it rough graph. And it will go like this. Steep. Eventually you have to find out what exactly is the intersection. Now this is 1. This is I don't know where it is it going to get intersected. It will get intersected. Eventually we will have to find that. So this is gone. This is not correct because unless and until you draw the graph to scale, you won't get the correct intersection of greatest integer function with x cube minus 4. And therefore, maybe, see, because greatest integer function is involved in the equation which is given to you, you are supposed to consider the jumping values of x while solving. And therefore, it is going to be more manual solving than algebraic. That is what is important because algebra will not provide you values of x 0, 0, 1, 2, 3, 4 like that. Algebra will provide you all values of x belonging to R. But because this function is greatest integer function, it is not continuous, it is jumping function, step function. Therefore, it is going to be more of trial and error, and you should get fair idea about what to try. So maybe this is easy question. If you try x is equal to 0, LHS is equal to 0, RHS is 4. So x is equal to 0 will not get you near the solution at all. If you put x is equal to 1, I mean, I am talking about greatest integer should be 1. So you are talking about the values of x between 1 to 2 now. So if I take value of x between 1 to 2, which is greatest integer 1, then the value of x cube, okay, now let us write it like this. X is between x is between 0 to 1. If x is between 0 to 1, then greatest integer of x is 0. And I cannot say LHS is 0. LHS is much smaller than RHS. Because RHS is 4 and square or cube of something which is between 0 to 1 cannot reach 4. Okay, therefore, this case 1 is not true. Maybe that is the correct representation. Case 2, 1 is less than equal to x is less than 2. So if you put x is equal to 1, then you still have 0 to LHS between 0 to 8 was a x 7. LHS is between 0 to 7, and that is what we want. So you have captured the range of x. If you put x is equal to 1, you get 0, 1 cube, 1 minus 1, 0, 1 minus 1 is 0. So LHS is captured between 0. And if you put x is equal to little less than 2, so you can calculate for 2. 8 minus 1 is 7. Therefore, LHS is caught between 0 to 7. That is what we want. RHS is also between 0 to 7. And then, once you know the greatest integer part of x is 1, you need to only find out the fractional part. And how are we going to do that? X cube minus 4 is equal to 1. Therefore, x cube is equal to 5. Therefore, x is equal to cube root of 5. I think that is the way to go. And then you can confirm by graphically, because this arm, upper arm, has to pass through the first. It is going to pass through the second dumbbell. Unless and until you sketch it, proportionately you will not get it. It has to pass through second horizontal line above x-axis, or the second dumbbell, 0 to 1, 1 to 2, wala dumbbell, it will cross this particular one. Have you understood? I mean, that is the way. I mean, you have to consider cases, find out which particular zone x belongs to, and do away with the problem. Next. Have you understood? Prove that product of two odd functions or two even functions is an even function. Let f of x and g of x be such functions that h of x is equal to f of x into g of x. Case 1, f of x and g of x be odd. implies f of opposite of x is equal to opposite of f of x, and g of opposite of x is equal to opposite of g of x. Therefore, h of opposite of x is equal to opposite of f of x into opposite of g of x, which is f of x into g of x, which is equal to h of x here. Another case is easy because there is no minus sign in y. Next, prove that every function can be expressed as the sum of an even and an odd function. Okay, let us look at the solution. F of x is equal to 1/2 2 times f of x is equal to 1/2 f of x plus f of opposite of x plus f minus f of opposite of x, which means f of opposite of x upon 2 plus f of x minus f of opposite of x upon 2, which is equal to say g of x plus h of x. So g of opposite of x is equal to f of opposite of x plus f of x upon 2 is equal to g of x. So this is e1. H of opposite of x is equal to f of opposite of x minus f of x upon 2, which is opposite of h of opposite of x, which is opposite of h of x odd. Hence proved. Breaking it into two functions is the important idea. Now, what we are going to practice is, given a function, find its domain. Practicing given function, finding its domain. So find the domain of is a heading. Question 1, y is equal to greatest integer log x to the base 2 for half, sorry, not find the domain, given function, sketch the function. After that, we will find the domain. So x should be between half to 4. Sketch this and show it to me. Okay. So again, a greatest integer function, and therefore you have to be good in sketching the curves to scale. Okay, so let us say that this is -1, this is 1, this is 2, this is 3, 4. Okay, then this is 1, 2, 3, 4. You are supposed to start from x is equal to half. So if you substitute x is equal to half in the equation, you get value of log x to the base 2 as -1. So your graph, this is going to be your first point. And you get, when you put x is equal, when will be the function equal to 0? When you put x is equal to 1, y is 0. So this point is also on the curve. When you put x is equal to 2, y is equal to 1, then this point is important to us. When you put x is equal to 4, then y is equal to 2. In this point. So for all practical purposes, your graph of log x to the base 2 is going to look like this. Okay. Then our standard procedure. If you have the graph in place, you draw horizontal lines. Horizontal lines at integer points on y-axis. Okay. You darken the intersections. Those points belong to your required curve. 1, 2, 3, 4. Darken them. And then from upper dark circle, you come down till you reach the next horizontal line. Get the hollow point and create a dumbbell. Get the hollow point. Create the dumbbell. Get the hollow point. Create the dumbbell. And this point. So my black represents the actual curve. E is required curve. Next. Y is equal to greatest integer 2 cos x between 0 to pi. Then, okay, one by one only we will go. Step by step. First, we know what is y is equal to cos x. We have it in your mind. 0, 1, 2, -1, -2. Okay, cos graph from cos is 1 when it is 0, cos is minus 1 when it is pi, and pi is 3.14. So this is 1, 2, 3.14. And therefore, this is over pi by 2. So cos will go like this, but 2 times cos will go like this. This is 2 times cos. Okay. Now, integer lines, maybe you can find out this value. Okay. When is it going to be 1? When cos x is going to be half. Cos x is half when it is pi by 3. Okay. Now you come down. Now you have to finish. From dark circle, come to the next line below with horizontal circle, hollow circle. Come down, complete the dumbbell, come down, complete the dumbbell, come down, complete the dumbbell. Is this correct? The blue one. अरे बरोबर आहे का?
Yes.
ते पाय बाय 2 आणि पाय बाय 3 मध्ये ब्लू लाईन वरती पाहिजे ना.
Log 2 greatest integer x. Between 1 to 4. Otherwise, किती काढणार? Now, I mean, this is easy because if x is equal to 1, okay, you can take it like this. 1 is less than equal to x is less than 2. Right? The value of greatest integer x is equal to 1, and therefore y is equal to 0 for this range. Between 2 less than equal to x less than 3, greatest integer x is going to be equal to 2, y is equal to 1. Between 3 less than equal to x less than 4, you have greatest integer x is equal to 3, correct? So greatest integer is equal to 3, therefore y is some value log 3 to the base 2. Of course, that value is going to be between 1 and 2. So 4 equal to x, you have greatest integer x is equal to 4, therefore y is equal to, so you have 0, when x is at 1, y is equal to 0. And it will continue till 2. At 2, it will be hollow circle. So this is the first one. when x is equal to 2, y is equal to 1. That's it. We will continue up to 3. When x is equal to 3, it is a dark circle here. Value of y is less than 3. So it is somewhere in between. This difference in these distances should be visible in your sketch. At 4, it is going to be hollow circle here, dead here. And at 4, y is equal to 2, so it is just here. Maybe this is 2, this is log 3, this is 1, this is the right, this is 0. Next, maximum of f of x is equal to maximum of mod x comma root of mod x between minus 2 less than equal to x less than equal to 0. Okay. So how will mod x look like? Minus 2 to 0. Minus 1 minus. This is how mod x will look like. And radical mod x, radical mod x is radical positive x for these values, which is a parabola. Y is equal to root x. X is equal to minus 1, y is equal to 1. So this point is going to be there on the other curve, y is equal to radical mod x. And it is going to be parabola like this. And hence the final graph is this is 0. Simple. Last one in this series, y is equal to mod of e raised to mod x minus 2 absolute value. And how much you should draw? Say minus 2 less than equal to 0 less than equal to 2. 0 9, so x. Between minus 2 to 2 we are supposed to sketch. So say this is 1, this is 2. Minus 1, minus 2. Okay. 2 raised to 2 is 4, so it is going to be greater than 4. 1, 2, 3, 4. Now suppose you have to start with e raised to x. Y is equal to e raised to x. So if y is equal to e raised to x, then e raised to 0 is 1. This point is there. E raised to 1 is e, so it is little greater than say 2.3 or something. Then greater than 4, maybe you have it here somewhere here. Okay, so this is going to be your e raised to x passing through this, and it will if you put e raised to -1, then it is 1 upon e, so it will be definitely less than 1. E raised to -2 is 1 upon e square, so the graph will go like this. This is the typical nature of e raised to x or a raised to x when a is greater than 1. Okay, now you are supposed to look at y is equal to e raised to mod x. So wherever x is negative, consider it as positive. This is making it symmetric with respect to y axis. So the graph is going to be like this up to 0, and then it is a reflection. In reflection in y-axis. Okay. Okay. Now you are supposed to do, maybe I should use correct notation, y is equal to e raised to mod x minus 1. It is simple. Panning down by 2. So the entire graph will come down by 2 units every point. So this will go to -1, -2. This will come here, and therefore it is just panning down. Now I am not considering what is x-axis, intercept, etc. It will intercept somewhere. You can find out that intercept anyway. When will y be equal to 0? When x is equal to, when will y? Acha. No, not -1, actually it is -2. त्यामुळे चुकलं. अजून खाली येणार. नाही, मी 2 ने केलं already. Okay, so this is what it is, something like this, and then you are supposed to take, maybe I will change the color, y is equal to mod of e raised to mod x minus 2. So what does this mean? This means whatever negative quantities you have in RHS, make them positive. So from here, it is reflection. So it is very sharp point at this point. And this is also very sharp. This is sharp, this is sharp. So for all practical purposes, your graph is going to look like this. And sharp corners at these points. There does not exist tangent. It is a cusp that we get here. Okay. Next job is to find the domain of.
Sir.
हा बोला.
सर या ग्राफ मध्ये x इज इक्वल टू 1 चे एक्सप्लेन करू शकता का? y 0.
Now answer for first is -infinity, -1, open, union, open, 4 to plus infinity. Answer for second is -infinity to 0, open. For third, there is no x which will satisfy this. Okay, now you find out the answer for fourth and show it to me. So for fourth, solution set is minus infinity, minus half, closed, union, open 0 to 1, open, union 2 to infinity. Next, fifth, y is equal to 1 upon log to the base 10, 1 minus x plus root x plus 2.